Okay, so today we're going to be talking about exponents and radicals. So we're actually going to do quite a bit of review from what you learned in ninth grade, and we're going to take that and use it to solve some more complex problems. Okay, so next page, first thing we're going to do is we're just going to go over our rules for exponents. So these should be relatively quick. Anything to the 0 power is 1. Anything to the 0 power is 1. Okay. When I multiply common bases, what do I do with their exponents? Yes, a to the m times a to the n becomes a to the m plus n. You add those exponents. A times b raised to the nth power. Say again? A n, b n. Yeah, what's the exponent for the a and the b in there? 1. When I raise a power to power I, multiply. Did she do this for you last year? Okay, when you raise power to power, you multiply. So we're multiplying through here. It becomes a to the n, b to the n. Okay, you got to make sure. That's a tricky one. You always have to remember to make sure if you're raising a quantity to a power, that that power goes to everything in it. Okay. Are you ready for the next page? Okay, I'll wait. Okay, a to the m raised to the mth is more rules. Yep. Raise a power to power u. We just said it. Multiply. When you raise a power to power, you multiply. So this becomes what? A to the n times m. Yep. Do I like negative exponents? How do I get rid of them? Good. Under 1. Okay. When I divide common bases, what do I do with their exponents? Subtract. Very good. Does it matter which one goes first? Give me another word for top one. Yeah, numerator. So this becomes a to the mth minus n. Any of this unfamiliar? No. Okay. A divided by b raised to the nth power. Good. A to the nth divided by b to the nth. Great. Okay, so those are just the rules that you have to know in order to be successful with the rest of this unit. We feeling pretty comfortable with these? Okay. So let's put them into use. Here's our first one. We have x to the negative 2 times x to the negative 3, all raised to the 4th power. Where do we start with this? Yeah, let's look inside those parentheses, right? X to the negative 2 times x to the negative 3. Do we have common bases? What do we do with the exponents? Add them. So this becomes what? X raised to the negative 2 plus a negative 3, right? You're adding those exponents. And then that gets raised to the 4th. All right. So what's negative 2 plus negative 3? Say again? Yep. X raised to the negative 5th power. And we're raising that to the 4th. Okay. Good. You multiply. And what is that when we multiply? Good. X raised to the negative 20th power. I don't like negative exponents. How do I fix it? 1 over x to the 20th. Great. Nice job. Feel okay with that? Not bad. Are there other ways to get there with this? Yeah, I mean, we could have gone right from here and said x to the negative 8th, x to the negative 12th, right, by distributing through that 4. And then we could have done x to the negative 8th minus plus a negative 12, sorry, which would give me x to the negative 20th, and then we could have dropped that. So it's a different way to do it, but we still wind up with the same answer. So there's going to be different ways to solve these, and you'll still get to the same place. So don't freak out if you did it a different way, okay? You guys ready? All right, let's look at the next page. Why don't you guys go ahead and give this one a shot on your own, and we'll talk about it in a second. Okay, so somebody tell me where they started. Okay, so what did that become? X raised to the negative 12. Okay. Times. Good. Well, let's finish what we have there, and then we'll talk about the negative. So now what can I do? Add those exponents. Yeah, so I get x to the negative 12. There's more than one way to do it, so you didn't do it wrong if you did it the other way, okay? Plus 4. And then we have that left over times 2. You okay with that? All right. They're like bases, x and x. Okay, so what do I do? Negative 12 plus 4, what does that give me? Yeah, x raised to the negative 8 times 2. Do I like that negative exponent? How do I get rid of it? Yeah, make it a fraction, right? Put it in the denominator. Where's that 2 go? It stays in the numerator. Why does it stay in the numerator? What's the exponent to that 2? 1. Is it a positive or a negative? So would I move it? No. So it stays right where it is. So it becomes 2 over x to the 8th power. Did somebody do it another way? And still get it right? Yes. That 2's got to stay in the numerator. Because essentially what you did, if you brought that 2 down to the denominator, you turned 2 into 1/2. And you didn't need to. Okay. All right, you ready to try another? All right, so give this one a shot and we'll talk. Too confused. All right, when we multiply at the top, we're just going to multiply everything together, okay? 2 times 3 gives me 6. Do we have any other x's? Leave it x. Do we have y's? Y to the what? You're making it way harder than you need to, right? Yeah. Okay, in the denominator, we got to leave that. We're not multiplying anything. So now when we get here, we can start to adjust, right? We have 6 over 3. What does that give us? 2. Where's 2 go? Numerator. I have 1x in the numerator, 2 x's in the denominator. I get an x where? Bottom, and it's always going to go where the larger exponent is, right? Y to the 6th, y to the 4th. Divided by y to the 4th. Y squared, where? Numerator. There it is. That's it. Easier than you thought? Okay, stop trying to overcomplicate things, guys. Trust your gut. Ready to try another one? Okay, give it a shot. Okay, guys. Anything to the 0 power is 1. So this becomes 2 times 1, right? Yes. What's 2 times 1? 2. So 2 squared gives us, there it is. You had 2x. Okay? Oh, it's too late. No, it's not. Just kidding. Wait, no, it's gone. Nope, it's back. Okay, let's try one harder. Go ahead, get a shot. All right, guys. Here we go. Numerator. 24. X to the 5th, y to the 8th. Do we all agree? Denominator stays. Okay, when I divide variables, what do I do with their exponents? All right, so 24 over 3, what's that give us? Where? Numerator. Okay. X to the 5th divided by x to the negative 3. When I divide, so I get x to the 5th minus a negative 3. X to the 8th, where's it go? In the numerator, good. Y to the 8th divided by y squared? Y to the 6th, where? So really, did I need this fraction bar? No, so there's your answer. How many of you got this right? Nice job, guys, very nice. Very nice. Oops. Good enough. Okay, good. All right, can I make this go away? All right, so let's start talking about radicals now. So I have The nth root. Who could tell me what that n stands for? What do we call that? Starts with an I. No.
What's the question?
This n, what is it? What is it? What do we call it? No? 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 Starts with an I. Want a hint?
Yes.
There's those, what? Good boy! Okay. I'm glad, that's okay. So it is index. Thank you for being honest with your cheating. It is index, okay? It's called the index. I didn't even get to my hint, which was going to be there's little cards that you write on. What are they called? Index cards, okay. A starts with an R. Radican. Okay. Remember, when we take the square root, it's always plus and minus. So what's the square root of 25? Plus and minus 5, okay? The positive one is what we call the principal root. That's what we use the majority of the time, except for when we're solving equations and things like that. So we will be using both the positive and the negative root, okay? All right, so let's take a look at this. Now, when we get into variables with exponents, we have to make sure that we are aware of what our index is. Our index is what's going to allow us to reduce those variables and their exponents, okay? So what is my index if nothing is written? Nope. Okay, let's think first. Tell me what the square root of 4 is equal to. Why is it equal to 2? Yeah, 2 times 2 gives me 4. It's what we multiply by itself to get the radicand, right? So how many equal factors did I have to break it up into? 2. What's my index? 2. Okay, so let's say I had the cube root of 8. How many equal factors would I have to break up 8 into? 3, which would be what? So the cube root of 8 is 2. So do you see where that index comes into play now? Okay, so my index here is what again? 2. All right, so this is going to help us to reduce this. What is the square root of 4? 2. Now, to take the square root of x to the 6, here's what you're going to do. Are you ready? Take your index and divide it into your power. What's the power? 6. So what's 6 divided by 2? 3. So the square root of x to the 6 is x cubed. So you divide that index into the power. The reason being is if I wanted to split up x to the 6, it's x cubed times x cubed, right? What's x cubed times x cubed? X to the 6. So that's how we break it apart, okay? So let's come down here and try this one. What's my index? 3. Okay, what's the cube root of a cubed? A. What's the cube root of b to the 6? B squared. Don't say b2, that drives me insane. It's not the same thing. It's b squared. Okay. What do you think? Not bad, right? Okay. Yeah, it's going to get harder. Are you ready? Okay, so with something like this, the first thing we're going to do is we're going to take and we're going to multiply our radicals. When we multiply radicals, what are we actually multiplying? What's underneath the radical? What's it called? Radicand. So what are you doing when you multiply? What are you multiplying? The radicand. Okay, so when I multiply the radicands, I get 2 times the cube root of, and if you lose that cube root, it's wrong, by the way, so don't lose it. 125, don't lose your index. Okay, 125, x to the what? Seven plus 4. Good Lord. 11. Okay, we're just multiplying the radicands. Okay. All right, what's cube root of 125? Do you guys know your perfect cubes? Let's talk. All right, what's my first perfect cube? 1. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is what? Can't hear you. 27. 4 times 4 times 4 is 5 times 5 times 5 is
125.
good. 6 times 6 times 6 is you have to have those memorized. Yes, really. Just like you have to have perfect squares memorized, you need perfect cubes as well. Okay? Okay, so again, I'll ask you, what is the cube root of 125? 5. Okay, so now I have 2 times 5. That comes out, right? But now I'm stuck with this. What's cube root of 125? 5. Just like if it was the square root of 4, it would be equal to 2. It wouldn't be equal to the square root of 2, right? Okay. All right, so now I have to deal with this. Does my index divide into my power evenly? No. So we have a problem, okay? I need to take that variable, this x to the 11th, and I need to split it up into 2, that one of which would be divisible by 3. Okay, so I'm looking, I'm going to multiply this just to get it out of the way. I'm looking to break up that x to the 11th into 2 so that that 3 will divide in. So what's the largest number that 3 divides into that's less than 11? 9. So I'm going to make this x to the 9th and x to the 2nd power. Yeah. So everybody see how I broke that up? What's x to the 9th times x to the 2nd power? X to the 11th brings it back. Okay, you're just splitting it up. So what's the cube root of x to the 9th? X cubed. Can I do anything with this? No. Cube root of x squared. There's your answer. 10x cubed times the cube root of x squared. That's it. You have to keep it. You can't just get rid of it. It's there. So these are obviously a little bit more difficult, right? Not really. Ready to try another? Okay, so I want you to multiply first and then break down. What do we get when we multiply, guys? What? Okay, so the cube root of 384 x to the 9th. Okay, so is your issue the 384? Start dividing it by perfect cubes. See what perfect cube divides in so that you could split it into 2 radicals. Okay, you're reducing radicals. You did this in 9th grade too. This isn't new. Just like if you had the square root of 27, how would you break that down? 9 and 3. Okay, so this would be 3 square roots of 3. You're doing the same exact thing here, except you're using perfect cubes instead of square roots. And we just went through what all those perfect cubes were. Hopefully you wrote them down. Okay? So think about it. Okay, so how did you guys break down 384? Yeah, cube root of 64, cube root of 6. 64 times 6 is 384. And then we have the cube root of x to the 9th, right? What's cube root of 64? 4. Gotta know your perfect cubes, guys. What's cube root of x to the 9th? X cubed. Why did I skip over the cube root of x to the 6th? Right. Can't do anything with it, so it just stays. So we have 4x cubed times the cube root of x to the 6, or cube root of 6. Ready to try another? Good? All right. Wait a second. Nope, just kidding. There is no more. Okay, so your homework is pages 2, 5, and 6. I want you to open up to page 2 and start it now. You got about, well, 5 minutes, a little less. I want you working, okay?